We enable a new type of connection between data centers around the world to enable something that goes beyond just the internet, something I might call the intercloud, where you're not sharing just files back and forth the way you do with the internet. You're actually sharing computational resources, computers, storage systems, networks, to create a cloud of clouds, if you will. Many data centers all working together as one. Data Gardens was founded back in 2007. We developed a way to use this ability that we generated to move virtual computers while they're still working back and forth across the world. So just moving the essence of the computer, all its operational processes and operating system, while it's still running from one part of the world to another. This capability became very highly sought after in about 2012 and after. And that led to actually the acquisition of Data Gardens and the movement to use our technology to enable the intercloud and the ability to move computers back and forth for various applications, disaster recovery, cybersecurity, a whole host of reasons. It's really the essence of what we do. The whole Data Gardens was founded based on an idea of how one could sort of trick networks into believing that these computers were moving back and forth, when in fact what we were doing was swapping an identical computer in the target location for the one that we were using in the source location. So we would create an exact replica mirroring all of not only the storage but also the memory and the active processes. And just in the flick of an eye, we were able to find a way to swap your activities from the source computer in one data center in one part of the world to a target computer in another part of the world, and you believe that you're still interacting with the same computer. You're always hoping to develop one new innovation that will really take things one step further. And there are many developments that we still like to bring to the market. The capabilities that we have certain limitations, and you're always trying to figure out a way to overcome those limitations and enable the next big step forward. So yes, always thinking, always trying to figure out something new. There's a team of software developers. Typically, we've had about 15 to 20 developers here in-house, but we've also been collaborating with University of Alberta, with Cyberra, with Canary. We've had many collaborations over the years, and even with Internet 2 in the US and Homeland Security, with the Canadian military, there have been many different collaborations that we've had as part of the high-tech community over the years. We're very interested in cybersecurity applications to the product, and the ability to use this intercloud capability to capture or identify cyber criminals and keep them in computers that they think are in production use but are actually honeypots where we can keep them in isolation and watch what they're doing. And so that's a very interesting application of the technology as well. There is a strong community, advanced technology community with IRAP, for example, Alberta Innovates, several programs funded by the Canadian government, which we were able to leverage to generate many millions of dollars of funding that could be injected into our technology and ultimately led to our success. The fact that the Alberta environment really stresses technology innovation and has several programs to support that really ultimately allowed us to develop a leadership position in our technology long before we actually started marketing our product. The ASTech program is very well renowned, and I've been following that community for a long time, so it's a very special honor. I feel very fortunate to be included as a ASTech finalist. It's important to diversify our economy and to build up the knowledge-based economy through innovation, I think, is the secret to breaking that boom-bust cycle. And so I think what you witness when you go to an ASTech Awards ceremony is all of that innovation encapsulated in one room that really is our potential for a future a little bit insulated from the boom-bust cycle. And I think it's critical. I think it's absolutely critical that we get out of the dependence on fossil fuels to develop a knowledge-based economy. What we do is enable computational systems to move wherever and whenever they are needed to different parts of the world. And that capability is actually, I think, something we will see as the seminal capability of a whole new world that is we're about to embark on, where the computational systems you work on could be here, they could be in Tokyo, they could be anywhere. It will be where they are most optimally designed to be. And all of your applications, everything from air travel to how your car works, everything will depend on this capability for computational systems to move freely back and forth the way files do today.